Hello everyone, and welcome to the 14th episode of CppNext. In this episode, we will discuss generators, a new feature we got in C++23. In C++20, we got coroutines, but we didn't have facilities for them. So in C++23, we finally can use those. What are generators? How could we use them before C++23? And how easy it is to use them in C++23 now? We will discuss all of this and more in this episode. So without further ado, let's start.
So what are generators? Basically, generators are functions that instead of just returning, they are yielding a value. That means when we will call the function again, we will get the next value. The easiest way to explain it is to use Python, because Python has generators for ages, and it's really easy to understand the language. So the most famous function that generates in Python called enumerate. Now let's see an example how to use it. So what do we have here? We have created a list of 6 values. Afterwards, we are using a for loop, but we are not just using the for loop. We are calling to a function named enumerate. This function is a generator. We are provided the container into the function, and it will generate the value from the container as if it's a for loop, a regular for loop in Python. But except that, it will also generate the index for the value there. That's why we see all those prints outs correctly. In index 0 we have 1, etc. The enumerate function works as a generator because it yields a value from the container, and it's done only when we looped over all the container. Now, let's think how we could write something like that in C++. Now let's discuss what we have wrote here. So in line number 7, we have a void pointer to an inner. We will discuss it soon. Afterwards, we have an actual implementation of our enumerate in C++, C++17. We shouldn't forget then that since C++17, we can capture new members to the lambda like this. We are just declaring that this lambda will have I that is initialized to 0 and j that is initialized to 0. Then we are just grabbing any container in, and we are marking the lambda to be mutable because most of the lambdas are not mutable and they will not be changed during the runtime. But in this case, we want it to be mutable because we will change the members. Afterwards, in line number 9, we are using the inner pointer that we declared in line number 7. And that is because we want to define and detect if the container was changed, I should be resetted to 0. So that's exactly what we are doing here. If the pointer to the inner is different than the pointer that we just received, that means that we need to change the pointers and reset I. Afterwards, we're just returning. So in line 10, we are using ternary operation that says if I is smaller than the size of the container, then j receives I++. That means j will be the previous value of I. Then we are using comma operator, our best friend, and we are saying that we are returning stud optional stud tuple of j and cont j. We will return a tuple of the index and the content of this index. If it is larger or equal to the size of the container, we will return stud null optional. That means that we will return something that will be false, quote unquote. In the main function, we are creating an array with 6 numbers. We are using a for loop where we are actually using our enumerate lambda. We are saying we will run until iv is valid because null opt is something that will be like false. And we are saying to advance, we will call the function again. Simple. Afterwards, we are using structural composition and we are unpacking the tuple into the structural composition, and we are printing it. And we got exactly what we wanted. It's a little bit complicated. It's more complicated than in Python for sure, but I try to make it as small as possible and to make it as usable as possible for people that don't have C++23. Now let's see how we can do it if we have access to C++23. As you can see, we got the same result, but with less code. And the code is more generic, and it's specialized with coroutines. It actually uses a coroutine and not something that looks like a coroutine or feels like a coroutine. All we had to do for this is include the generator header inside this file, to use return type of generator. In our case, it's tuple of int and int. Create a function that receives any container. Use a for loop that is okay since C++20, where we are defining a new index and looping for each value inside the container, and co-yielding. That means when we are co-yielding, this function will stop at line 9, return the value, basically the tuple that we created, and the main function will continue running. When we will call the function again, it will continue from the same spot. That means we will get to line 8, and we will take another index and another value and print it out. This generator will stop if and only if we looped all over the container that we are looking at. So it's safer, it's cleaner, it's easier to use. And if you have C++23, please use generators and learn more of the amazing abilities that we got with C++20 and 23. As always, like and subscribe, and I will see you in the next episodes.